Hello again. This is another video about my 4-bit Minecraft CPU. This one will be a tour and explanation of how it works. So, over here is the ALU. Basically the way it works is it's connected to the two registers here, and so they don't have to do a bunch more extra wiring. It's that this D flip-flop is part of the A register, this D flip-flop is part of the B register, A, B, A, B, A, B. And they're fed into these wires, which are the same thing, and they go into each adder and subtractor and any other logic gate for the logic functions. And then there is basically a multiplexer which selects which function you are doing, because this is one of the decoders in the CPU that takes the opcode from the um, from the instruction given from program memory. And so if it's any one of these, it will select which function, like this wire. If the opcode were the number 4, it would select this wire, and it would go up here to select ORing. And so then when it's selected, each bit goes through this wire and into this big downward bus going down here and going into the C register. And basically how this works is whatever is in the A and B registers is always being fed into the ALU and is being computed in every function all the time. So then when one of the functions one of the opcodes comes up that requires that function, it is selected, and so the certain output for that function goes onto this bus. And then also, whenever any of the opcodes for this is selected, it goes up here and activates this wire, and this wire goes all the way over here and updates the C register. So then also, guess I'll show the branching, the conditional branching now. For each D flip-flop of the A and B registers, they go up here into these XNOR gates up here, these piston XNOR gates, which looks like that. And they're basically XOR gates, but here is an extra inverted. This is basically the output inverted. And so it goes into this big 4-input AND gate that's really stretched out, so it can reach every XNOR gate. And then when this wire is on, it means that the two registers are equal, and then this is basically an inverted version of it that says that they're not equal. And they go into these AND gates, and whenever one of the conditional branching functions is called up, either to jump if they're unequal or equal, these decoders decode it out, and it goes on to one of these wires, and it goes into one of the other AND gates, and if the condition is met, it goes into this OR gate, and then it goes on this wire all the way down here to update the program counter, which on the bus going into it has whatever number is being fed into there from program memory. And then this is basically the clock. When you press this button, this is a monostable circuit, and it will this torch will flash on for 1 tick, and it will start this clock. It is This clock is, I guess, a 12 clock. And every time this input goes on, it updates, it increments, I mean, the counter. And whenever this part goes on, it goes down here into this circuit, which basically just stretches out the current. And it goes into here, and this allows the opcode to go into the CPU and get decoded into whatever data needs to, in whatever needs to be done. And then the numbers also go onto this bus. And then this is a selector where if the, I have no idea why these two blocks are here, but if it is selected that this input is needed, it will go onto here, go onto this main data bus, and go into each D flip-flop with a register, but only the certain opcode that updates that register will go and update all the D flip-flops in that register. But so also, over here, there are also some other decoders for copying the value of the C register over over to either the A or B register. And these two decoders right here are for that command, and they go and update either the A or the B register. And then over here, the outputs for this decoder are basically ORed together, and then they allow the output of the C register to go onto this long bus, which is the same bus that the inputs to the registers came on from program memory, and they go onto that bus and go into the registers. And I think, well, also for the program counter, it will select a certain number, 0 through 16. Well, no, 0 through 15. And it will go into this big decoder, which will select a line in program memory, which still has that program loaded in from the previous video that added 2 plus 3. And it will select one of these lines, and one of these wires will turn off, activating the torches there, and that is the instruction. And that is it. That's pretty much everything about it. So, goodbye, see you in the next video.